Number 1 was in slope-intercept form. So you really just had to start graphing. Start at the 3, go down 5 and over 2, and draw that line. For the second one, start at the -1, go down 1 and over 2, and you'll see that they cross at the point 2, -2, right? Really quick check, those are both negative slopes, so you should at least know that you have 2 negative slopes going on. You had a 50-50 chance, right? All right. So you go on the x-axis and find that 4, and it's always 4 for x, which means it's vertical. And so for this first one here that they gave us, you just find your 4 on your x, and it's just the line that goes through 4. Had it been y, it would have been a horizontal line. All right, so that's an easy line. The next one, they did not give it to us in slope-intercept form. You can certainly put it in slope-intercept form if you like graphing that way. But remember, you can also graph with intercepts. You can graph with intercepts. So for my x-intercept, I would just zero out my y, and I would have x equals -4, which means I go to -4 on my x-axis. And then for my y, I would just zero out my x, and I would have 2y equals -4. So y equals -2. So I go to -2 on my y-axis. And then I can connect those 2 points to graph that line with intercepts. If you want to put it in slope-intercept, subtract your x, divide by -2. And you'll get divide by 2. You'll get -2, and then you go down 1 over 2. With a -1/2 slope. But either way, graphing by intercepts or graphing with slope-intercept, you'll still get your final answer of 4, -4. So on this one, I'm going to look at the easiest one to get substitution. The x and y are kind of by themselves, but the y has a -1 in front of it. So if I were to try to get that y in the second equation by itself, I would have to divide everything by -1. So I would actually get the x by itself. All right, so I would take this top equation here, and I would just subtract that 4y over. All right, so this cancels, and I have x equals 0 minus 4y. You don't even have to write the 0, all right? You can just write -4y, all right? And once you have that, you can take that -4y, and you can substitute it into that second equation for what x is, all right? So since x equals the -4y, I'm going to go to my second equation. Instead of writing x, I'm going to write -4y minus y equals -9. All right? This is not even distribution. This is just multiplication, right? 2 times -4y is -8y minus y equals -9. I need to combine my like terms. -8 and -1, that's -9. And then I'm going to divide by the -9. So I have y equals +1. Y equals +1. Now that I know y, I can go back to my equation and substitute. Again, x equals -4 times 1. So x equals -4. So my final answer here is -4, +1. We do have an x with a -1 in front of it, and we do have a y with a 1 in front of it. So I can either multiply the top equation by -3 to make that a +3 and a -3, or I can multiply the bottom equation by -2, and I'll get a +2y and a -2y. It doesn't matter which one. So we'll just take the top equation, and we'll multiply by -3. All right, so -3 times -x is +3x, -3 times 2y is -6y, and -3 times -7 is +21. And then I can add these bottom 2 equations here. So I have -3 and +3 cancel. I have +1 and -6 give me a -5, and +21 and -21 give me 0. So 0 divided by anything is just 0. So I have my y. Now I can choose either of these equations to plug my y back in. So if I take that top equation, then I'll have -x plus 2 times 0 equals -7. This just zeroes out, so I have -x equals -7. You need to divide by -1 for both sides. X equals 7. So 7, 0 would be your answer. So if I look at this, I have a 7 and a 4. I need to get the least common multiple between those two, or an 8 and a 5, least common multiple between those two, all right? And so it doesn't matter which one you eliminate, you're gonna have to multiply both equations by something. In fact, you're gonna have to multiply one by a positive and one by a negative, because these are all negatives here. So if I just take the top equation, if I multiply that one by a negative 4, that will give me a positive 28. And if I multiply the bottom one by positive 7, that will give me a negative 28. And so that will cancel my x's, all right? So if we multiply all the way through, we'll get 28x plus 32y equals positive 4. We got to multiply everything by negative 4. For the bottom one, 7 and negative 4 gives me the negative 28. 7 and negative 5 give me a negative 35. And 7 and 2 give me a positive 14. Positive 14. Now I have something that will eliminate and I can add. All right. Positive 28, negative 28 cancel. 32 and negative 35 give me negative 3. 4 and 14 give me 8. So y is going to equal negative 6. Once I've done that, plug it back into one of these equations. So negative 7 times x equals negative 8 times negative 6, which equals negative 1. And then just solve. This is going to give you 48. Subtract negative 7x equals negative 49. Divide x equals positive 7. Let's look at this one. So a motorboat makes the 24-mile upstream trip. Against the current is 3 hours. With the current is 2 hours. All right, so it's the same 24 miles. Remember, our equations here are rate times the time will equal the distance. All right, so if I am going against the current, my rate is going to be whatever my boat is plus, minus my current, right? Against the current means the current's taking away from how fast I'm going. The current is literally pushing against me. All right? Even if they don't tell you, that will be the longer time. It will take you longer when something's pushing against you. So this going upstream or against the current took 3 hours. The total distance was 24. All right? When they came back, they were going with the current. That means the current was helping. The boat was helped by the current, so we add those two, and the time was 2 hours, same distance of 24. Now, the easiest way to do this is to go ahead and divide out those hours, because you will already have a plus or minus set up when you do that. If you don't go ahead and divide out the hours, you're going to have to multiply these equations and get big numbers, all right? So I would go ahead and divide this equation by 3. So I'm dividing the group by 3, and I'm canceling that out. And 24 divided by 3 is going to equal 8. Okay? And I'm going to divide this by 2, and the 24 by 2, which will equal 12. So that will leave me b minus c equals 8, and b plus c equals 12, right? Now I have a perfect elimination problem. I can add it. My c's will cancel. I will get 2b equals 20. So the boat is going 10 miles per hour. If 10 minus a number is 8 and 10 plus a number is 12, the current is obviously 2 miles per hour. You just plug it in. 10 minus the current equals 8. Subtract 10. Negative c equals negative 2. C equals 2. And so that would be your answer. All right, so for the first one, you started at your slope-intercept 3. Your slope was negative 5 over 4, so down 5 and over 4. It's a solid line because you have the or equal to. Y is bigger, so you're going to look at Y. Y is bigger on this side of the graph, so you're going to shade that side of the graph right there. For the next one, it is not in slope-intercept form. You can use your intercepts though, or you can put it in slope-intercept. But using your intercepts, if I were to just cover up my Y, I would get 2x equals 2. So my x-intercept is going to be 1, which is right here. If I were to then cover up my x, I would get y equals 2. And so my y-intercept then would be at 2. So I already have 2 points there. This particular one is dashed. Dashed because I do not have an or equal to. I do not have an or equal to, okay? Now, to determine which way I'm going to graph, I have to look at this y. If there is a positive in front of the y, I'm going to graph it however it looks. It's smaller, so I graph below it. If there is a negative in front of this y and I did not put it in slope-intercept form, you're going to graph on the other side because remember a negative will flip this sign, okay? So if you leave it in this standard form, pay attention to whether you have a positive or negative in front of your y. All right? Questions on just graphing 2 lines here. -2 is where I start. My slope is up 1 over 1. It is a solid line because it's or equal to, and it is below the line. So I would have graphed, if I were shading this, I would shade everything below this line. All right? For the second one, I start at 3, and it's -4, so down 4 over 1. This is a dashed line because it is just less than. And to shade this one, I'm shading below the line as well. So it's going to be on this side of it. And so you'll notice on the graph, when they graphed it, the only part that is darkened is that one wedge right there. And so that's your answer right here, just this wedge. All right. For the second one, neither one was in slope-intercept form. They were both standard. So if I do my intercepts, if I were to zero out my y, my x-intercept for this first one is 3 right here. For the y-intercept, if I were to zero out my x, I have -y equals 3. So that means the y-intercept is -3. -3, all right? It is a dashed line because it is not or equal to, so dashed. It is greater than, but where did they shade? They shaded below it because there is a negative in front of the x. There's a negative in front of the x. So if I were shading this line, because there's a negative in front of the x, I would actually shade below it. If I don't put it in slope-intercept form, I have to pay attention to that, okay? For the next one, my y-intercept, if I were to zero out my x, is just going to be 2. So my y-intercept here is just going to be +2. For my x-intercept, if I were to zero out my y, it's actually going to be a fraction, which is fine. It's going to be 1/2. And so my x-intercept here was at 1/2. This is also dashed, but this is greater than, and it stayed greater than because we didn't have any negatives in front of the y, so I would shade above it, which would be right here. And so you'll see when they graphed it, they only graphed one part of it, which was that wedge at the bottom right corner, and that would be your answer for this one.